Okay, so let's look at the binomial cumulative distribution. Okay, now basically what's happening here is this is the case where you're not just calculating a single event occurring. Okay, this is the case where you're calculating multiple combinations and multiple probabilities. So I'll show you what we're doing. Let's continue to look at this example. All right, boys and girls equally distributed. The probability is equally likely. Calculate the probability that in a family of 6 children, okay, let's go to C, there are at least 4 girls. Okay, so at least 4 girls means we have a couple of possible situations. We could have 4 girls and 2 boys. We could have 5 girls and 1 boy, or 6 girls and 0 boys. Okay, are there any other probabilities? The answer is no. Okay, so what we're effectively doing then by using the BCD is we're adding up all these probabilities. Okay, so what it looks like then, I'll show you what it looks like, and we're going to do it a much simpler way than that. Alright, what it looks like is we have the combination, okay, out of 6 kids, 4 girls, okay, and the probability of it being a girl is 0.5 to the power of the number of girls, and then times that by the probability of it being a boy, which is also 0.5, and that's to the power of 2, okay. So that is this first circumstance here. But we're saying the probability of this circumstance and that circumstance and that circumstance. Okay, so what we're effectively doing then is adding it to, we're adding in 3 circumstances. So in the circumstance of 5 girls and 1 boy, what's changing here? We have 5 successes, okay, and this circumstance here, 6 successes, okay, and 0 failures. Okay, now I'm just putting these numbers in here just to show you exactly what we're computing. Okay, you can definitely simplify this, alright, but I just want you to become used to that process. This is exactly what we're calculating, but that can be quite tedious to put into our calculator. Okay, so we use the BCD function when we're talking about multiple events or multiple probabilities. Okay, and what it is a calculation of is the probability of x being less than or equal to some number. Okay, so for example, if there are 4 girls, we could have 2 boys, 5 girls, 1 boy, 6 girls, 0 boys. Okay, now again here there's 2 ways of doing this, alright, and the first way that I'm going to show you, I think, is the most practical, okay, because it helps us to think of only using this BCD function. Okay, so it's the probability of x being less than or equal to some number. Alright, so what we're saying is if there's 4 girls, then the most boys that we could possibly have in this whole circumstance is 2. Okay, so what we're effectively calculating then is the probability that the number of boys is less than or equal to 2. Okay, so we're calculating the case when there's 0 boys, 1 boy, and 2 boys. Alright, now the reason we basically flip the question around is because the BCD function only calculates probabilities for less than or equal to. Okay, we can't change it to be probabilities greater than. Okay, so what we're calculating then is the probability of x being less than or equal to 2. Alright, and I've just done the less than and the underscore there to show. I'm not sure how to do that symbol without inserting it, so I'll just leave that. That just means less than or equal to 2. Okay, so the way we're going to do this, alright, is we go into our statistic function in the main menu, distribution, binomial, and we're now doing BCD, binomial cumulative distribution. Let's click on that. Okay, now our number of trials is still 6. 6 trials, okay. The number of boys, okay, we're saying the probability of X being less than or equal to this number, 2. There could be 0 boys, there could be 1 boy, or there could be 2 boys. So 2, this caters for the case of 0, 1, and 2, and the probability is 0.5. Okay, so let's execute that. The answer that we get is 0.344. Okay, so if you check that in the back of the book, that should be the right answer. Okay, now part D is exactly the same as part C. Okay, just because the probabilities are the same. Okay, and if there's at least 4 girls, that means most of the children are girls, and D asks for most of the children being boys. So the probability is going to be exactly the same.